Hi,
Hi. Hello. Hi.
and I would like to ask Christian to please introduce yourself. Yes.
Yeah, my name is Christian. I work for Novatech Consulting, and I like to use Kotlin. Well, that's the first thing I want to say. I'm kind of a Kotlin fanboy, to be honest. And one reason for that is because the outstanding support of Kotlin in Spring and Spring Boot, and that was my introduction. So I'd say almost 4 years ago, I switched completely to Kotlin and use Kotlin mainly as backend programmer so far. And as we are an independent contractor, of course, we have a look at other frameworks as well, not only Spring and Spring Boot, which we really like to use, but of course, there's Micronaut and Quarkus and Kato and other promising frameworks. And when you look at those frameworks, you always try to adapt what you already know, what you've learned using Spring Boot. And some things work really easily, and something are rather different. And yeah, that's what the session is about, especially when it comes to mocking. There are tiny bits and pieces that need to be done in another way. If you come from a Spring Boot background, for example, and the experience we made, that's what the session is about today.
Okay, just to confirm with everyone who is watching, this will be a pre-recorded video that I'm going to play, and you can ask Christian your questions in the meantime. He will be in the hop-in chat, so while the talk is playing, you can, in real time, ask him your questions. And now I'm going to play the video.
Hi folks, welcome to my session about Supersonic Subatomic mocking. My name is Christian Schwörer, I work for Novatech Consulting, and to say it right up front, we use Spring Cloud and Spring Boot rather often in our projects, and we're happy to use it. Nevertheless, within the last months and years, we've seen new frameworks which do things a little bit different. And among Kato, Micronaut, Quarkus is the most interesting and relevant for us. So today I'm going to give you an introduction how to test parts of your Quarkus application using Kotlin. So what can you expect from this session today? As I already mentioned, I try to give you an introduction how you create tests, or to be more precise, to test parts of your application. It's not about how to create an end-to-end test where you start with your REST application and test your application way through to your database, for example. It's more about testing a unit or a service in your test and mock stuff around it away. And as the Quarkus application was created with Kotlin, we're going to use Kotlin to create our tests as well. Furthermore, we're going to use JUnit as testing framework and MockK as for mocking stuff. If you heard of one of these technologies, very good. If not, no problem. I will give you a short introduction, and today is more about how to combine these technologies. I will try to give you a practical introduction. That means we're going to switch to some code in a minute, or let's say in 5 minutes, something like that. On the other hand, what you won't get today is a deep dive into one of these technologies. So we won't go into deep what is Quarkus or what is MockK, etc. It's more about, as already mentioned, how to combine this stuff and see that your application behaves as it should. And with that, I come to my disclaimer. Sorry, I have no silver bullet and probably no best practice for you today, because these are things that work for us, that are the good practice for us with our technology stack, with our testing approach. I don't know you. I don't have the hybris to say this is how you should do everything or everything else is wrong, because I don't know your domain, I don't know your team, I don't know your technology stack or your skill set, etc. So today it's about an inspiration, what works for us, and I'm pretty sure that there's something which you say this is worth having a deeper look or further look at afterwards. So before we see a short introduction to Quarkus, I need to do a short excursus about resource efficiency. What is it and why is it important? So in my opinion, I think resource efficiency has two dimensions. The first is the startup time of your application, which you need to be as small as possible. And the second thing is the memory consumption of your application, which also needs to be pretty low. And why is it important? Well, if you create an year and you deploy it to an application server which runs for days or months or years, I don't know, startup time is not really relevant. If your application runs for 3 months, the 10-minute startup time is probably fine, fair enough. But if you're in the dynamic cloud environment where you have dynamic load scenarios, new requests keep coming in, you need to scale your application horizontally and start new instances, and you need to start them now. Not in 10 minutes, now. Or perhaps you have a CI/CD approach where you deploy your application several times a day. Yeah, suddenly startup time matters. Or if your cloud decides, oh, this instance looks broken, I start it again over there. So if you're in this microservice cloud native environment, startup time matters. Especially if you run your applications in a container, because normally a container limits your resources as well. Perhaps you just have one CPU or you have not that much memory. This is even more crucial if you're going towards serverless, because in serverless you have the scale to zero approach. Your first request triggers your instance, and yeah, if that takes 10 minutes, obviously that's not a good fit. And concerning memory, well, you're in the cloud, you can say, okay, we just buy more resource, more memory. But at the end of the day, you need to pay for that. And if you can run 2 instances with 2 GB of RAM or 1 instance with 2 GB of RAM, well, with 2 instances, you can serve more requests and it's a better fit for your cloud native application. So normally as an application developer, you don't get so much in contact with your resources because you have all these abstraction layers above your resources. But if you want to do things cloud natively, you need to keep in mind that resource efficiency matters. Or let's phrase it this way, or with this quote, the less efficient your application, the more profit the cloud provider makes, because you need to buy more resources. Yeah? And with that, I'm coming to Quarkus, a pretty resource efficient framework, or as they describe themselves as a supersonic, subatomic Java. Supersonic means they are very fast, especially when it comes to startup time. Subatomic means they are pretty small, for example, if it comes to memory consumption. What Quarkus is, it's a Kubernetes native Java stack, and they have 2 target platforms. The one is OpenJDK, so you can create just a normal JVM application. And the second built-in target platform is the GraalVM, which allows you to create native images where you can gain even more improvements concerning startup time and memory consumption. If you have a native image, that's another dimension if you come towards resource efficiency. But that's a little bit out of scope today. As mentioned, today we are just application developers who want to test our applications or part of our application. Then Quarkus has a container-first philosophy. I already kind of mentioned that. It's a small disk size, fast startup time, low memory consumption. And how do they achieve this? Well, let me try to compare it what Spring Boot does, because Quarkus sets himself pretty much as a competitor or alternative to Spring Boot. And what Spring Boot does is when they resolve their framework logic, they use reflection, runtime proxies, class bar scanning, dynamic class loading, all very powerful tools if you create a framework. But they come at a price. And the price is these things are done at startup time or at runtime, which decreases which has not a good influence on your startup time and your runtime behavior, or your memory consumption. Let's phrase it that way. And what Quarkus does, like other frameworks, Micronaut says, we shift the framework resolution or the resolving our framework logic to the build time. We don't do stuff at startup and at runtime, we do it at build time, which means they have an ahead of time compilation approach where they resolve all the framework logic, and at startup time you have a completely reflection, runtime proxy free application. So this is in a really short way the difference between a framework like Quarkus and a framework like Spring or Spring Boot. And one last sentence to Quarkus. The dependency injection of Quarkus is based on CDI. If you have a JE or Jakarta background, you probably heard of that already. Context and dependency injection. We're going to see that in a minute in the example. Oh, one thing I forgot. They say they have a best of breed of Java libraries and standards. That's pretty much, if you have a JE or Jakarta background, you're going to find, or you can reuse your skills, because you find libraries you already use, like JUXRS or Hibernate and stuff like that. So if you have a JE background, getting there is pretty easy. The second framework we're going to use today is JUnit. And I assume most of you have heard of it or probably already used it. And at least since version 5, it's I would say the de facto standard for a JVM testing framework, or like they say, the shaping the future of testing on the JVM. The nice thing about JUnit is, especially as a Kotlin developer, all the things you know from Java can be used with Kotlin almost the same way. Or let's phrase it that way, almost all functionality feels completely identical. There are some tiny bits you need to consider, and we're going to see one of them later on, but most of the stuff, almost everything works out of the box for a Kotlin developer as for a Java developer. And the third framework we're going to use today, or third library, is MockK. We're going to use it to mock stuff away. As mentioned, we're going to create an isolated test and mock stuff around it away. And we could use Mockito. Perhaps you know Mockito, a very popular mocking framework in the JVM world. And Mockito is also a extension for Kotlin. But to be honest, you need to do some hacks when using Mockito. For example, every class in Kotlin is final by default, and that somehow contradicts the approach of Mockito. So it's a little bit hacky, yeah. And yeah, MockK is created from scratch for Kotlin, so you don't have to use these hacks. And for example, you have a very nice DSL to describe your mocking behavior. And for the Kotlin guys and girls of you, you also can mock extension functions and stuff like that. So we're going to see that in a couple of minutes. If you're a Kotlin developer and you think about mocking stuff, I can recommend using MockK. So that's it already with the introduction. Now, before switching to some code, as promised, I will need to describe you the scenario, the application we already have, and we try to create some tests for it. So I stripped down the application to a very simple example. The reason is I don't have the time, or I don't want to bore you with half an hour how the business domain is. So I decided just to create a small superhero registry. This means we have a registry where all our superheroes like Batman, Superman, Wonder Woman, Black Widow, etc. are registered, and we can ask the registry, give me all superheroes. So far, so trivial. Yeah. This application is created with in Quarkus and Kotlin. And to give you a short overview is we here have a REST consumer, might be a single page application or any consumer as well. And this calls a superhero resource here. For the Spring Boot developers of you, in Spring Boot, this would be a REST controller, and Micronaut it would be a controller. In JUxREST, we call this a resource, but you're going to see it feels the same as a controller. The superhero itself has auto-wired here a superhero service, and you already see this is a CDI bean. The superhero service contains our business logic. I say business logic because you're going to see it's very trivial. It's just so we can test anything at all. The superhero service itself has dependency to the superhero repository. Perhaps you heard about, this repository approach or this repository pattern if you use Spring data or Micronaut data or stuff like that. It's an abstraction for the data access. Yeah, and our superheroes are stored in a database. Yeah, and a superhero has several attributes here. It's probably a little bit too small, so I'm going to read it to you. A superhero consists of an ID, a name, like Batman in this example, a location where he lives, like Gotham City. He has a real name because, Batman is Bruce Wayne, so that's his real name. And Bruce Wayne has an occupation. He works as a businessman. So this is our superhero entity. And now our superhero service, and here we have the business logic, says, okay, I can't give out that behind Batman there's Bruce Wayne. So this is really secret. So the superhero just anonymizes our superhero and says, okay, there's just Batman and his location is Gotham City. So this has some kind of anonymized function in there. And this is the so-called logic. This is the overview of the application you're going to see in a minute. And what we create later on is we're going to create a test for the superhero service and mock away our superhero repository. And we're going to create a test for our superhero resource and mock away the superhero service. So these are isolated tests we're going to create. So switch to the application. First of all, I'm going to show you some code. And yes, let's start with the superhero resource. So the REST interface we provide. And here you see as already mentioned, in Spring or Micronaut, this would be a controller here. In JUxRS, which we use, it's just superheroes, a certain path, and here you see if this is called, if you call superheroes with the HTTP verb get, and you provide a path parameter with an ID, this function is executed. And what does this function here? Well, it extracts the path parameter and it calls the superhero service find superhero function. And here you see the superhero service is wired with dependency injection. We use constructor dependency injection here and just say, okay, auto wire this superhero service here. And we have two more functions here. If you call superheroes without a path parameter, you get all superheroes, not just one. We also call the superhero service here. And the last one is if we do a post, so HTTP verb post, and just provide a superhero, we need to add a superhero and return a created HTTP response with the status code 201. So in this case, we just create a status code 200. Yeah, that's it. So let's have a look at the superhero service here. Here you see this is annotated with application scope. Application scope, well, marks it as a CDI bean, and it says application scope means, well, kind of like a singleton. In the whole application, this thing just exists one. Yeah. The superhero itself has also here constructor dependency injection, a dependency to the superhero repository or data access abstraction. And for the moment, we're going to focus on the find superhero. The function we have called provide an ID, and we just call in the repository the find by ID. And if we switch to the superhero repository, so this is a panache repository. As already said, if you know Spring Data or Micronaut data, I think GORM, the Groovy Object Relational Mapping, has also some kind of this approach. We implement here the interface panache repository in our class. Here, once again, it's a CDI bean marked with application scope. And we get, if I go back here to the superhero service, a find by ID. I didn't declare that on my own. This is done by convention, and I get a complete list of convenient, let's say, CRUD applications. Here, stream or count, delete, etc. I don't need to take care of that. I just say here in my repository, this panache repository manages superheroes. And a superhero is declared here, is just a data class. Well, in Java, this would be either the POJO with the getter setter hash code equals to string, copy, clone, whatever you need. Or I think, is it Java 16 or Java 15, something like that. You have the records where you can also just declare your domain object. And this is, in Kotlin, you have this since ages. You just say this is a data class, and this represents our superhero. A superhero is already mentioned as an ID, a name like Batman, a location, Gotham City, a real name, Bruce Wayne, and an occupation like businessman. And this is just here JPA annotations, entity and ID generate the ID database, or JPA or Hibernate to be precise, should create our ID for this superhero. So going back to the superhero service, if we have called or we have retrieved our superhero, which we try to retrieve by ID, we call this business logic anonymize extension function here. And if you look here, what the anonymize does is it just says, okay, and superhero just consists of a name and a location, and forget about Bruce Wayne and businessman, because we cannot hand that out to our customers or to our consumers. So this is what we're going to test in a bit. So this is it, mainly our application. It's just one thing. I've created this. You wouldn't do this in the real application. This is just to create some test data. This is a startup bean which says, okay, whenever this application is started, I just put in there 5 superheroes already. We have Superman, which is Clark Kent. We have Batman, which is Bruce Wayne. We have Black Widow, which is Natasha Romanoff. We have Black Panther, and we have Spider-Man already in our database. So if I go here to Postman and do now a get on localhost 8080/superheroes, I should get back my 5 superheroes. But of course, I don't know that Spider-Man is Clark Kent and works as a reporter because our anonymization logic works. Or if I do a superheroes/1 I only get Superman. Yeah. Oh, I said that wrong. Of course, Superman is Clark Kent, not Spider-Man. Yeah, see, it works. Okay, this is our application. I'm gonna stop it for the moment. Where's my terminal here? So, and now we create a test for the superhero service. So let's create a test here. And so I don't have to type that much. I already created a live template, superhero. So what we have here is a plain unit test. Okay, one step back. You probably all know the testing permit. I didn't make an extra slide for that because you all have pretty much seen it 1,000 times, but you all know the test pyramid where you say, okay, you need lots of unit tests because they're easy to implement and run very fast. You have a couple of integration tests. Sometimes it's hard to decide, is this still already an integration test or still a unit test, but you have a couple of integration tests. They're also rather easy to implement, take a little bit more time, and you have only some end-to-end tests because they are hard to maintain and take their time to be executed. So first of all, here we created just a plain unit test, our superhero service test. And you can see here, our testee is just instantiated. And we say here, okay, we can instantiate it. And we hand over, what we do here with constructor dependency injection, we just say, okay, create a mock. This you can see with MockK, we created a mock and say, hand this over. Yeah, and our testee is instantiated. Then we create a test function. Here you see a JUnit at test, and you can see in Kotlin you can write, if you want to, you can write your function names like this. You don't need uppercase, lowercase, camel case, snake case, kebab case. You can write your functions like this. Don't do this in productive code, but this is a test function which I would never call, which is just called by the JUnit framework. So here's a nice way to describe what this does. It says, okay, get an anonymized superhero by ID. So first thing, all the tests you're going to see are done by the AAA pattern. First, we arrange our test, then we act, we call the real code, and then we do the assertion. So first, the arrange is, we say, okay, this is the MockK DSL. Whenever repository find by ID is with 42 is called, we return a superhero with these attributes. Then the act part is there. Testee find superhero, we really call our testee. And after that, the assertion part, well, this is expect that. This is the Kotlin, strict Kotlin assertion library. If you use SRJ, that would be assert that. And just say, okay, we expect the what we get here is just the mocker in mock city and not with the whole attribute. So we see that our anonymization works. So let's try to run it. Okay, still compiling a little bit. But as it's a plain unit test, it should be rather fast. Okay, still compiling. Okay, the assertion didn't really work. Okay, spoiler, I did that so you can see it really works. Here we say we expect the location to be Mock City, and here we return a superhero which lives in Stuttgart. So if we say here, okay, the mocking behavior was wrong. If we rerun it, yeah, just a plain unit test. I think nothing really surprising. But honestly, if I only want to test my superhero service, and that's all the logic that is in there, this unit test might be sufficient enough. What else should I need to just, if I want to test my superhero service, isolate it? So we need to add something more here. And this is, I'm gonna cache the result. Well, first of all, this is really a bad example for caching because this trivial database access is not a good way to cache something. On the other hand, caching is a good possibility to show you how we can test Quarkus stuff. We can test something that the framework provides us. So, disclaimer, Not a good example for caching, but caching itself here is a good example to extend our test. Just imagine this would not be just a find by ID. This would be something which takes ages in the database, or perhaps a different service you call, and the data is rather static, so it only changes, I don't know, once a day, and perhaps caching might be an option for you. So we're switching back to our test. We just say, okay, we want to also see if caching works, and see if caching works. So now we have to change here a little bit to see that. This is the first result. And we call it again and say, okay, the second result is this. Okay, the assertion here is still valid, but we say expect that second result is equal to first result. Yeah, we expect if we call it 2 times with 42, the result should be the same. And now we once again use MockK and say verify repository find by ID 42. And now we want to say this should only be called once. Yeah, we call our service 2 times, but the service itself calls the repository only 1 time because the result should be cached. So let's rerun it here. Oh, no tests were found, of course. I've renamed it. And this doesn't work. It says, hey, you call the repository mock 2 times. Well, yeah, this is not possible to work because the caching here is a notation provided by Quarkus. And our stupid small unit test knows nothing about Quarkus. So what we need to do is we somehow need to promote our plain unit test to a little bit more integration test. I'm not sure if it's really an integration test, but it's more integrative as just a simple unit test. So first of all, we just say here Quarkus test. And for the Spring Boot developers or Micronaut developers, this would be Spring Boot test or Micronaut test, which kind of does the same. So we're going to start the application and use the real application to run our tests. So here we don't instantiate our application. We say use the real CDI bean, add inject, and do here late init var. So I run it, and this will take some more time. As mentioned, this is not just a unit test; it's more integrate-ish. Which means in the background now Quarkus is started and we use the real CDI bean here and say, okay, do this stuff with the real CDI bean. So you see, okay, it's really slow. This results as I'm recording, and normally you can develop or you can record, but normally both at the same time is not a good idea. But we see, okay, first of all I want to show you, it really starts Quarkus in the background with all the features I have defined in my POM. But it says, oh, the assertion is wrong because, yeah, you expect this to be returned, but the repository returns null. Okay, what does that mean? Well, actually we've created a mock here, but Quarkus knows nothing about this mock. Well, this is just a mock in our unit test. We need to say to Quarkus, take this mock instead of the real superhero CDI bean. And therefore, we need to add here something. We say a before all, this is JUnit, we say before any test function is executed, please execute this, set up mocks. And now there is a feature you can use, Quarkus mock, install mock for type, and now we say repository for superhero repository. So we say use this repository, our mock, whenever a CDI bean of the type superhero repository is used. So we're going to start it again. So we say, hey, Quarkus app, replace the real CDI bean with our mock. So this might work. No. once again, it fails. And here you see, now we get an error by JUnit, not by Quarkus or text execution. It says the before all method must be static. Okay, and this is something I mentioned earlier. Normally everything in JUnit works for Java the same way as for Kotlin, or other way around, for Kotlin the same way as for Java. But there are some tiny bits and pieces you need to be aware of. And this is one, because to sum it up, static behavior in Kotlin is different than in Java. And one way to solve this is to say we create a companion object here. And move this up. And with the companion object, we have this possibility to say here, JVM static, and just say to the Kotlin compiler, please generate a static method out of this. So normally JVM static you need if you want to interact with Java or something like that. So test is started again. Takes some time because Quarkus is started in the background. And now it's executed. Here. Oh, and it works. Great. So what have we tested? We created a mock. We created our testee. We tested that the business logic works as expected, and we tested that the Quarkus caching works. So pretty nice test, I'd say. Still readable, but to be honest, I'm not really happy with this companion object here. But because at this point you need to write more code in Kotlin than you would have to write in Java. And that's rather unusual. Normally Kotlin is more idiomatic and more concise, and this somehow, at least it's I think it's a very good way to do this, but it somehow feels not that right. And with that I come to an extension, a Quarkus JUnit 5 MockK extension. This is extension you're going to see in a minute. Just to say it right up front, a nice extensions with an awesome feature, but it's in version 0.0, and you see here it's not that well maintained, to be honest. It's only 6 contributors. I think one of them is me, which doesn't count because I just changed some documentation stuff, and 2 are some bots that just did some dependency updates. So normally this is just maintained by one person, and it's not the best maintained. Nevertheless, it's really nice, what you're going to see in a minute, to use, because we can get this more declarative, the whole thing here. So I can throw this away. I can throw all this away. We don't need this anymore. And I just say here, add inject mock. And we can do this await init var, and don't need this also. So just gonna start it and tell you what really happens here. So this extensions allows me to just declare, hey, this is a mock, create me a MockK mock, and inject that in my Quarkus application. And cross your fingers, hopefully it still works. Quarkus is still started. Test is executed. And it's green, it passed. So, as mentioned, perhaps it's not the best maintained framework, but right now it has everything you need if you want to use MockK with a Quarkus app. And from my perspective, it's just test code. So the worst thing which might happen is that there is a breaking change in your test code. Perhaps it's not a good idea to use something in your productive code that early, but for me this is okay. If it isn't supported anymore, I just need to add what you've seen earlier here. So I can recommend use this this extension here. Okay, so this for the moment our small test where we test a little bit of the logic and see if caching works. What I want to do is to create a test for our superhero resource. So for our REST interface you've seen earlier. Create a superhero resource test, and also created a live template, superhero resource test. So what you see here is, this doesn't make sense to create a unit test, a plain unit test for this, because what we're going to test here is if JSON serialization and deserialization works, if certain exceptions are mapped to status codes, if all that is going on in this REST interface. And this is done by the framework. So if this is reachable, I cannot do it in a unit test. I need some kind of more integrative or kind of integration test to do this. So we created here a Quarkus test. And I use what you've seen a couple of minutes ago, the MockK extension for Quarkus, and say, create a superhero service mock and inject it into my Quarkus application. And then you here see our test. And once again, we have this AAA pattern. First, we arrange our test and we say, okay, if the superhero service is called with the ID 42, then return an anonymized superhero. And, okay, we can do that. Just give me a second, a little bit more readable. And then here comes this is a little bit act and assert in one thing. This is rest assured. Perhaps you've seen it before. There's nothing Quarkus or Kotlin or MockK specific. It's just a framework that allows me to create HTTP request, and we say this is the act given when I call superheroes 42, and this is the assert part. Then I expect the status code of the response to be 200. Okay, the content type should be some JSON, and the body should be equal to the JSON I declared here. So what we're testing here is if the object is serialized to the correct JSON. So let's run this here. Once again, Quarkus is started in the background, which normally is very fast, but yeah, when recording, the CPU and the whole laptop is under stress. Okay, but test is green. We have checked that this thing here works. So let's add here another test. For example, I'm going to copy that here and say get for unknown ID. So here we can say, yeah, don't return a real object, just return null. We don't need this here, and we don't need this here. And we can say, okay, for. So if the service returns nothing or null, we want that the REST interface gives us a for. I don't know if it's this proper REST, but I declare it that way. I'm going to run our test. And hopefully the first one still works. And the second says, okay, we get a 200, but we expected a 4. Okay, so let's have a look at our resource. Yeah, that's we always return 200. If this provides us null, we just wrap it in a response 200 and say, here it is. So we need to change this implementation here because obviously it's not done the right way. So what do I need to do? Okay, we just extract that to a variable and say val superhero. And yeah, the easiest way, or probably very good understandable, is if I say superhero not null, then return return response okay with the superhero, else response dot status not found dot build, and return this. Run our test again. So, to be honest, at this point, having your application first and creating the tests afterwards is not really a good practice, I would say. If you do some kind of test-driven development, you normally have first your test, and your tests fail, and then you create your application. And for demo purposes, I mixed that up. Yeah, otherwise we would have not enough time. But you see here, at least now we have the capability to say, okay, we expect here to be a 404, and now fix our application. So, and if you're interested in Kotlin, I just show you some. I think this is a good, readable, nice code. Yeah, but if you're interested in a little bit more Kotlin, I show you something. I'm not sure if it's better readable, but it's at least more Kotlinish or more Kotlin idiomatic. We can use a function here, a scope function, and say if this is not null, return it. And here we have an Elvis operator and say if it's null, return this. So we don't need this anymore, and say here return. So, and the good thing is, as we have a test, we can refactor whatever we want, because, or let me phrase it that way, if you have no tests, refactoring is kind of Russian roulette. It might go okay, but you can shoot yourself. So now we have a test and we can refactor our application and see if this still behaves as it should behave. And yeah, still okay. So this might be the more Kotlinish way to do things. So looking at the watch, yeah, I think we still have some time to create a last small test here and say return get a 500 for exception. So if the service throws an exception, returns. For the moment, we just take a simple runtime exception. So we say not null, not a real object, just throw an exception, and then we expect here status code 500, rerun it, see if this works. Well, to be fair, this is that the framework manages to map any runtime exception to status code 500 is normally something you should not test. Normally you have your special own exception, like a user not found exception or a user not granted exception or something like that, and you map it in your REST interface to your own status code or specific status code and test that. This is just to show you how the DSL works if you want to return an exception here. So, still works. So, switching back to the slides, what have we done so far? We have tested our superhero service in an isolated test. And we have tested our superhero resource in an isolated test. What I won't test is our superhero repository here, because if I switch back to the code, the superhero repository, there is no function I can test. Well, I need to trust that the punish repository find by ID is implemented correct. And there probably someone who knows the whole panache more than me has tested that well. So from my perspective, I wouldn't write an isolated test for this. What you could do now is create, you have tested this isolated, you have tested this isolated, create an end-to-end test, which calls the whole, let's say, the happy path, just here one time through and calls the whole thing, and start your test container or something like that, where you have some superheroes and it is returned here. So you have tested this isolated, and now you see that they stick together. That's the thing, the last thing I would do in this case, but we're running a little bit out of time, so yeah, let's wrap it up. Quarkus is a really nice framework, and it has a lot of drive, and there's going on very much in Quarkus. But to be honest, I would choose Quarkus, but you need to be aware that it's around for about more than 2 years, and it cannot be there concerning feature completeness and ecosystem and stuff like that, where frameworks like Spring or Rails, who have been there for ages, are. So they put in a lot of effort, and there are new things coming up, and it's really happening a lot. But for example, if you look on Stack Overflow and you have a problem with Spring Boot, there is probably someone who already had that problem, and perhaps there's already someone who have solved the problem. With Quarkus, that's not every time like that. So be aware of that. It's leading edge. It has some nice features, but be aware there might still some feature be lacking. And it is Supersonic, Subatomic Java. Everything I've seen so far works with Kotlin, but the documentation is mostly Java and the examples you find are mostly Java. So sometimes you need to dig in a little bit deeper if you want to use Kotlin. For example, here you see this is from the generator where you create your application. It still says Kotlin is in a preview state and the Hibernate ORM with Panache in Kotlin, you've seen the repository, is still in an experimental state. So be aware. It works. So far, I've found nothing that did not work, but some things might change there. And I've shown you the extension, the Quarkus JUnit 5 MockK extension, which I really like to use, but also be aware it's not in a final state. That's it from my side. I hope you found something interesting, something inspiring today. I'm looking forward to your questions in a bit. And if you're interested in that, I wrote a blog post about the whole theme. And there are some more details about Kotlin. Things that don't work with Quarkus, for example, for the Kotlin guys and girls of you. Normally we use nested inner classes in Kotlin to structurize our tests. That does not really work in Quarkus tests so far. Yeah, so some bits and pieces are still missing. If you're interested in that, have a look at my blog post in the Novatech blog. Of course, you find a GitHub repo with all the examples. And if you want to contact me, you find me on Twitter. My DMs should be open. And looking forward to your questions in a minute. Thanks and have fun today. Bye.
Okay, and now there is some time for questions. Allow me just 1 second to apologize for the earlier mistake. The video seemed to have slowed down for a second, but then it was solved. So sorry about that. So there have been 2 questions during the stream from Thorsten Seitz. I'm sorry if that's incorrect. So he asked if your types don't already ensure that no secret information can escape. So you have the anonymized superhero, which holds only the name and the city, right? So doesn't the type itself ensure that no secret information can escape?
Yes. He's right with that. By using not the entity and not handing out the normally you would just delete 2 attributes or 3 attributes of the entity and hand out the entity. But I decided to create a new, let's say, DTO or something like that. But implicitly, it is already impossible to hand out the name of Batman, the real name of Batman, and his profession as the handed out property or the handed out object already doesn't contain these values. So he's right. It's a little bit, let's say, to create a small example I can show, that was the compromise to do that. But fair question, good question.
Not really sure I understand that. If your code gets a bit more verbose, but it's more descriptive, then isn't that a good solution? Isn't that a better solution than just handing out the entity with attributes deleted if they are not available to the end user anyway?
I tend to do that. I normally try to keep the entities to the, let's say, repository or the data access part, and just map it to DTOs. But the DTO does not contain a name and the real name and the profession. So the kind of, to be honest, this business logic. If you just make sure that your service doesn't hand out entities, it's not possible to hand out the hidden information.
Right. Okay. So, and he also asked, and I think you mentioned something about recording. Why does it take so long for Quarkus to start? Wasn't one of the advertisement bullets points of Quarkus fast start at times? And I think you mentioned in the video a couple of times actually. So this might have been answered in the video that you were recording and that ate up CPU. So
yes, it's definitely due to the recording. The whole laptop or setup is really busy when recording stuff. Normally, this application starts on my MacBook in less than a second, but to be honest, what is not really important is how fast it starts on your laptop. It's more important how fast it starts in your environment, your cloud environment, in your container. And there's even more difference between something like Spring Boot with this reflective approach and something which has this ahead of time compilation approach like Quarkus. So yeah, it should start faster. And like you mentioned, Michael, yes, it's a little bit due to that my laptop is quite busy recording stuff. It's even worse when you stream stuff.
Right. So when you start it up on your own, it's faster.
Yeah.
Okay. Okay, and that was all the questions from the audience. I had a very simple question. When you copy pasted the test, it occurred to me that it's just as simple to write the same thing with parameterized tests, right? Where you could pass the input and the expected output, for example, that's a bit more concise, I would say. So it's all the JUnit bells and whistles, all the little things, they all work, right?
Yes, yeah, you could use parameterized test in that. Well, I didn't use them because in this rather easy example, I don't want to add too much complexity, or not complexity, too much features of JUnit. But yeah, would be a good approach. You think in the resource tests or in the service tests?
Well, if you test basically the same logic, for example, you get you ask for something and you get an answer. Then it's very easy to pass the two things into a parameterized test. Say that I want this and I expect this. And if you have like 4 or 5 tests, then I found that it's sometimes more verbose, but more easier to understand if you write it out, even if it's a bit more redundant. Because it's just easier to see, to read, and it's not complicated code. So even if there is a bit of redundancy, it's just easier to understand, and you don't have to, like, there is this thing when you maintain something, there is this second or minute where you have to look at the code to understand why it was written that way. And sometimes parameterized tests, they are just more complexity for no reason. Sometimes it's just easier to have 2 or 3 tests that are simple. So you look at them, oh, it works like this, done. Or you look at the parameterized test and go, okay, so it does what? And then you have to parse it and then understand it, and it takes 2 minutes. So just it's not worth the effort, and it's the same amount of time to write. So but sometimes I think that it's worth.
Yeah, I think you're right, and you need to keep that in mind. Try to make it as readable or as maintainable as possible. And if you have lots of parameters and lots of variances where you say, okay, we need to test these several inputs, a parameterized test might be suitable. But if it's only 3 tests, perhaps, yeah, like you mentioned, it's more suitable to say, okay, let's create 3 separate tests. And if one fails, I need just to have a look at the one test and not, okay, which one of these parameters created the failure of the test. But yeah, I think it depends on the situation.
So I'm also trying to look at the chat, but it seems that no one has any questions apart from Torsten. Can you help me out? I think that's a German name. How do you pronounce it?
Torsten Seitz. I said, sorry, I missed that in the video. I assume he missed me complaining that my MacBook is too slow because of the recording.
It's fine. So yeah, I apologize again. I ventured into familiar territory for me because I am not really familiar with either Kotlin or Quarkus or MockK. I'm only familiar with JUnit, so I ventured towards JUnit questions. But you gave me an example, so I'm going to ask you your example question. You said that Quarkus has not as good Kotlin support.
So, yeah, if you compare it to, let's say, the Quarkus support, the Kotlin support of Spring Boot, which is really outstanding, or the whole support in Spring is really outstanding, they are not there yet. And well, is it a good choice as a Kotlin developer to switch from Spring Boot to Quarkus? Once again, it depends. I think it might be a good choice. And since version 2 of Quarkus, they added a lot of more Kotlin stuff and more support and so. But still, they cannot be there where Spring is. So, yeah, keep that in mind. It's a little bit leading edge, which might give you good advantages, but it has some drawbacks, as always, if you choose a technology.
Right.
From my perspective, I'd rather stick to Spring than switching back to Java, to be honest.
Okay, you said the leading edge, which leads into your second thing you wanted to mention. So I'm going to ask that too. So Quarkus is known, I didn't know that, you helped me out here, full disclosure. Quarkus is known for its built-in support of GraalVM native images. So that is something to consider when you want to switch or not, right? So do you use GraalVM support?
Yeah, well, first of all, it fits very good. Well, they promote it. They have two target platforms, the JVM and the GraalVM. And the good thing is, well, the GraalVM is a little bit tricky if you have lots of reflection. It's not that it's not doable, but you have to declare every reflective behavior separately. And as Quarkus gets rid of all the reflective code by doing this ahead of time compilation and doing everything at compile time, it's a perfect fit for the GraalVM. You don't have to configure anything, oh, this will behave like this during runtime. Yeah, so I think it's a nice option to have the GraalVM and the whole scenario to create a native image where your startup time is like 10 milliseconds and the memory you use is about 30 megabytes or something like that, not a gigabyte. But at the end of the day, you add some complexity to your whole build process and to your whole application. Because you have this, you create a JVM application and you test it with JUnit and everything is green. And then you take your jar and hand it over to the GraalVM and say, hey, GraalVM, create me a native image. And then somehow you need to retest that again, or otherwise trust completely the GraalVM that everything is fine. So this works perhaps if you have just a small function, like a serverless function, where you have just a little bit input parameters and a little bit coming back. But if you have kind of a bigger microservice or even service where you cannot retest everything in your native image. And there are things to consider. So I would say that for 80 or 90% of the applications I have seen so far, or I know the GraalVM approach is still a little bit early. And yeah, you also miss what the JIT compiler does. It optimizes your code through runtime. So the compiler sees, okay, this is executed very often. I optimized that. This is executed never. So I don't care of that. If it's a native image, everything is treated the same way. Your throughput might even be, in certain cases, better using the JVM or the JIT approach. So yeah, it's good to have that option. Is it something everybody should use everywhere? I don't think so.
Okay, so the time slot is up, but if I check the schedule, I'm fairly certain that yes, there's a short break after this. So I'm going to ask you for this just last question, just for a personal opinion, if you want to share. Do you think that Spring has a dominance over the market share of the back end server side? So do you think that Quarkus can break into it and other frameworks can break into that?
Well, at least in my perspective, or what I see in our project, Spring is the de facto backend framework for creating services or distributed services. Let's phrase it. It doesn't need to be a microservice, or don't want to get into that discussion. But you see that let's say, they see that there are new frameworks like Micronaut or Quarkus or Kato that get rid of this reflective overhead. And there's a lot going on within the Spring world as well. You see the Spring Native project, which makes good progress. The Spring Foo, which is a more DSL-ish way to describe a Spring application. So there's no much auto magic in there. And I think from a developer perspective, there's the opportunity, or there's the possibility that other frameworks will find their place in the whole ecosystem, and you have the choice. it's not you have only this tool and you need to use it everywhere. You have more choices, and from developers perspective, I think that's good news.